And in this video, we're going to talk about containers and containerization and Docker. And I've got the app that we just saw deployed to Heroku. I've got it running locally on Windows inside of Docker. And I'm going to talk about what it took to do that. So you can see here it is running on local host, looking exactly like it looked before. This is sort of the control panel of things that are sort of operating right now. I've got two containers set up, one for my database and one for my application. And I'm going to, I'm not going to show you how to do it locally on Windows because I imagine most of you are running Windows Home Edition and Docker does not run in Windows Home Edition. And so I've got Windows Enterprise for my college laptop. That's how I was able to install what's called Docker Desktop. There it is right here. So with Enterprise, I was able to get Docker Desktop. There were a few students last term that realized that Microsoft had this like student deal where you could get your machine upgraded to Enterprise if you showed that you were a college student, but it did something funky with their machines and it like stopped them from being able to log into like any college infrastructure. So it was not a good scene. They spent a lot of time sort of trying to rip out what they did there. So the alternative is if you really want to run it locally, because there are marks for like getting Docker running on your local environment. Docker has a product called Docker Machine, which is specifically for running Docker inside of a VM. So we're going to talk a little bit about what containers are, but this allows you to get a VM, a Linux VM that is running on your machine inside a VirtualBox, and then to put containers into it so that they're not running on Windows, that they're running inside of a virtualized environment. So it is a possible thing. I don't have any experience with Docker Machine, but if you wanted to go that route for those marks, you could. What I'm going to show you today is how to get Docker running on a virtual private server. So if you want to get like a VPS or a virtual private server, you have to pay for it. I'm going to show you one that doesn't cost all that much. It's $5 a month, but it also charges out per hour. And so you can just like spin it up for the time that you need it and then like turn it off. And so it won't cost you too much money. But yeah, the alternative is you could use Docker Machine. So before I get too into the weeds though, let's talk a little bit about what is a container. This is something that I'm still trying to wrap my mind around. And so I hope everything that I'm going to be saying today is accurate. But I find like whenever I pick up a new piece of technology, initially I'm a little bit cloudy on a lot of things. And like I'll work some of it out while talking it out today with all of you. Does anyone here have experience with Docker or containers in general? Okay, so if I say anything that sounds ridiculous, please feel free to interrupt. So what happened to me is on Monday night. So I was going to do the lecture with the other section on Tuesday. And I thought, okay, before I do that, Tuesday night, I'm going to quickly spin up the containers that I put together last term just to make sure everything's working. And then I was like, oh, but that last term we were using Rails 5.2. There wasn't like the Webpack in there. I'll quickly make one for Rails 6. And while I'm at it, I'll run Rails in production mode. Because last year I only did development mode. And then I had like a 2.5 hour battle with Docker and Docker Compose. Very frustrating, mainly centered around the fact that I didn't really know what the heck I was doing. Like there was enough gaps in my knowledge that I was doing things that I should have known were wrong, but I was just operating on like partial understanding of Docker and a whole lot of Googling. Like I had like 400 tabs open at one point. And I was like, oh. Anyways, I never solved it, went to sleep. And when I woke up in the morning, I had the solution. So like Dream Kyle solved the problem. And like I woke up and I was like, yeah, and I ran down to the computer downstairs and it's like one line changed in my config file and boom, it all worked. And so like you can actually dream solutions. This I've proven a number of times. It's pretty awesome. It was a good feeling. It was a fitful sleep. I kept waking up and being like, Dockerfile, and then like going to sleep. And so, yeah, there's that. So what is a container? Docker says that it's a standardized unit of software. And of course, I sort of talk about Docker and containers as being interchangeable, but like I said in the last lecture, containerization as a thing has been around for a long time. It predates Docker. They really popularized it though, and they've tried to standardize the idea around what a container is. And they are right now sort of the de facto standard of containerization. And the thing that confused me specifically is the difference between containers and virtual machines. And these pictures here, so I'm just on the Docker website. These pictures helped me figure out the difference. So we have virtual machines on the right here and containers on the left. The green layer here, they call it the infrastructure. You can sort of think of this as like, it doesn't necessarily have to be the bare metal, but this is like whatever is provisioning your CPU and your RAM. Like this is the computer, this infrastructure layer. With a virtual machine, you've got full operating systems. These might be Linux operating systems, it might be Windows operating systems. You've got them running in a virtualized environment, sitting on top of or within a host machine. And you've got a hypervisor that's sort of mediating the guest machine's ability to interact with the infrastructure. So when the guest machine needs access to CPU, needs access to RAM, that's all being vetted through this hypervisor. But you can think of, when you're within a virtual machine, you can think of it being an entire clone of a machine. It acts like it's a full operating system. It is a full operating system. Right? The difference with a container is you're not containerizing the entire OS, you're containerizing just your application and its dependencies. The operating system that you're going to be dependent on is the host operating system. And so when we containerize a Rails application, we're going to containerize the app itself, so like the source code to our app. We're going to containerize along with it any of its gem dependencies, so all like the bundle dependencies, any of the yarn dependencies, those are all going to be in our container, and also the OS level dependencies, so like anything that we have to install by way of apt-get. All of that goes into a file folder structure, but we're not containerizing the OS. So Docker is sitting at the bottom of all the containers that are running on a particular machine, and it is allowing them to access like the kernel layer of the host operating system. So that seems to be the difference here, is that here you have a bunch of operating systems sitting on top of a hypervisor to get to the CPU. Here you have a bunch of containers that are sitting on top of Docker, allowing you to directly access the host OS. The one thing that I still don't get, like this model makes sense to me when the apps are all containerized Linux apps and the host OS is Linux. But when the apps are all Linux apps and the host OS is Windows, I still don't get that. Like I don't know how that works. If they're like doing something like the WSL where it's like converting kernel calls that are like Linux kernel calls into Windows kernel calls, that's still a mystery to me. I don't understand that part of containerization. But this model does make a lot more sense to me when the host OS is Linux. So you can think of a container as like, when you run a container, it's almost like you're running an app inside of your regular operating system, except for the app is not just the app, it's the app and its dependencies that are sort of cordoned off or sort of black boxed off from the rest of the operating system. So there's some security sort of firewalling in place, right? Like your app cannot reach out to the other apps running on your host system. You shouldn't be able to, like, if there was like a virus or some kind of malware inside of one of your containers, it should not be able to mess around outside of itself. I'm sure there are some possibilities there, but yeah, it's running in what's called user space inside of the host operating system. So that's the difference between virtual machines. We're not grabbing an entire OS. In the early days of Docker, they would talk about like the containers being like really small as well in terms of like file size. but I've not found that to be the case. I found that like when I create what's called a Docker image, which leads to a container, the images end up being actually really, really big. Sometimes they can be like 1 or 2 gigs big. And for like just a single Rails application, it feels like that's a really big image to be associated with a container. I found a few ways to slim down those images, which I'll talk about as we proceed. Conceptually, how does that sound? Does that make a little bit of sense as to like the difference between a container and a VM? And as I said, like I'm still trying to work this out, and I'm hoping that I'm not lying to you. So on any of these things, yeah, I think just conceptually, you can think of it like it's almost like a virtual machine, but it's much more lightweight. Okay, so how do we actually go ahead and set these things up? Well, it's pretty nice. It's done by way of configuration files. So I've got another version of the same app that we built today. This is one that I built with the other section, and there's three files I'm going to pull up. One is a .dockerignore file, and this follows the same format as a gitignore file. And as part of our process, we're going to be moving large chunks of our application or copying large chunks of our application from our host machine into the container. And the dockerignore file just specifies like, ignore these files and paths. These are things that do not need to be copied over into the containerized environment. So things like the whole .git folder, that doesn't need to be in the container. The other two files that are crucial is Dockerfile and Docker Compose. And so I'm actually using two pieces of technology here. I'm using Docker and Docker Compose. So Docker Compose is something else from the Docker organization, and it is what allows you to sort of manage multiple containers and have those containers interact amongst themselves. So you could think about like, if app A here is my Rails application, app B here might be the Postgres database. And you want the Rails app to be able to, by way of a network, connect to the database. You want to be able to expose the Rails app by way of a network sort of to the outside world, but you don't necessarily want to expose the database to the outside world. And Docker Compose is going to sort of set that all up for you. It's going to create a virtual network that will allow your containerized Rails app to connect with the containerized Postgres app, and it will then also expose the containerized Rails app to like the network at large, the internet at large. So we're going to first look at the Dockerfile, and this is how you set up a Docker container. The Dockerfile covers the steps that are going to be required to make a Docker image, and then you're going to be able to run at the command line like Docker up on a particular image, and that will make your Docker container. As I said, I'm going to be using Docker Compose, so when you do see me run commands, they're going to be Docker Compose commands, and it's sort of like a higher level of abstraction on top of Docker that's going to manage not only my Dockerfile, but the separate instance of Postgres that I also want to be containerized. I'm going to take a little bit of step away from Docker for a moment, and I'm going to log into my DigitalOcean account. So DigitalOcean is just a virtual private server company. So what they do is they have a whole bunch of actual hardware, like just rooms and rooms of servers, and they slice those servers into like virtual machines that you can then buy from them, and they sell them for fairly cheap. So like the cheapest of their plans is like the $5 a month plan, where you get a virtual machine that has one virtual CPU and 1 gig of memory. And that'll actually go quite a long way. There was a time where I was running with a buddy of mine about 40 different domains off a single $5 a month VPS. And the neat thing about it is if you need to scale, you do have to, it does involve a little bit of downtime, so it's not as slick as having something that's sort of auto scaling, but you can take your, what's called your droplet, that's what they call their virtual private instances. You can take it temporarily offline, and you can bump it up to a higher tier plan. So when we run our election websites, a few days before the election, we bring the website down, we scale up to like the $80 or $160 a month plan, and then we just run that for like the few days before the election, day of, day after, and then we scale it down after that. And they only charge you, if you scale up to this $80 a month plan, they're charging you per hour 12 cents an hour. Whereas the $5 plan is a fraction of a cent an hour. It's 70% of a cent an hour. So if you're going to play around with this, you do have to give them a credit card, but you can create your instance. While it's up, you're paying a fraction of a cent per hour. And after you destroy it, you can't just put it to sleep. If you put it to sleep, they keep charging you. But after you destroy the droplet, then they don't charge you anymore. So it's quite affordable to play around with. And I'm pretty sure you can get free hosting. There's a few ways. The GitHub student pack, does that still exist? This, you just have to tell them that you are a student, and it comes with like $50 credit on DigitalOcean. So that's a cool thing. And then there was like, I think there's at the end of my here's the marketing guide. I have like an affiliate link in here at the very bottom here for DigitalOcean. Yeah, there's a link that'll get you $10. So if for some reason, sometimes the GitHub student pack gets a little bit backed up and they don't sort of authorize you right away, you can follow this link. It gets you $10 free credit. So that's like 2 months on the cheapest plan. And then if you end up ever spending $25 on hosting, my not-for-profit organization will get a bit of money. They'll get $25 in credit on the platform. So you can use one of those ways of getting a little bit of free hosting on DigitalOcean. So I'm going to sign in here and show you how easy it is to spin up a droplet. Just got to do my two-factor auth. Okay. So I have one long running droplet that is sort of the server that I use for a lot of client work and whatnot and the election stuff. I'm going to go to this create button, create a whole bunch of different things. I just want a droplet. I could just create like a vanilla install of one of these flavors of Linux, but there's also a marketplace. And on the marketplace, you can get like all sorts of pre-installed software. Anything from like GitLab, MongoDB, MySQL. So it's going to give you a Linux environment that has this stuff pre-installed on it. And I want the Docker pre-installed because that just simplifies things. It's no more expensive. There it is right here. And what that's going to give me is it's going to be Ubuntu with Docker Community Edition pre-installed. So that's Docker's free offering and Docker Compose. So that's great. So I'm going to create that. They're a little bit tricky here. They make it look like $40 is the cheapest plan, but it's really $5. Right? But that's, I mean, hey, why not? That's marketing. Let's, just to speed things up today, I'm going to splurge on you and I'm going to spend 12 cents for this lecture. I'll go with the $80. 24 cents is just too much, though. I'm sorry. I'm just going to cut it off at 80. No. That's why I'm splurging here. You get to pick which region you want to deploy the server to. This is important if you are building a business in Canada. If you want to ensure the privacy of your customers' data, you want the server that you're deploying to be on Canadian soil. If you put your server in the US, based on certain laws in the States, your server can be accessed warrantless and all of your data potentially exposed by US law enforcement. So yeah, it's better to have a Canadian server. This is a problem with Amazon Web Services. There are certain products within the Amazon ecosystem that are just not available in Canada. And so I just like the fact that DigitalOcean has the option of a data hosting in Toronto. I'm going to do this. This is going to inject my public key, my SSH public key into the server so that I don't have to use passwords to log in when I SSH into the box. So it's just going to be, I'm going to be authorized for that machine. And then I'm going to give this a host name, Docker in class Disposable. And I'm going to create this droplet. And the droplet's just going to be up, like I'm not going to have a domain name associated with this droplet. It's just going to be up at a bare IP address, but that's fine for what we need to do, which is just like bring Rails up at a particular port. So I'm just going to bring it up on an IP address, and then after class, I'm just going to destroy this droplet and it'll go away. So we'll give that a moment. Actually, I'll just let that happen behind the scenes, and we can investigate back into here. So when you're building a Docker image, you always start with a base image. And you could start with the base image being just like default, some flavor of Linux. I went with a base image of where Ruby is already installed. So similar to that marketplace where we're doing like a pre-installed version of Docker here, Docker has this thing called Docker Hub, which is sort of like GitHub, but for Docker images. And so there are base images for all sorts of things. And so I just went on here and I searched for Ruby, and I found the official Ruby image, and I clicked on it, and I saw that the latest version that they have that wasn't a preview version was Ruby 2.6.5. So that's going to be my base image. So this from the very first thing when this Dockerfile is being built, it's going to grab that base image and it's going to build everything on top of that. Later on, when I need access to Postgres, I'm going to base that off of the official Postgres image, which is a pre-configured version of Postgres, all set up, ready to go. You just need to provide it with one environment variable as to what password to use for the default Postgres account. So you can search through Docker Hub. You can find all sorts of great Docker containers for all sorts of things. So that's step one, base image. Next thing up, I'm just setting an environment variable that I'm calling Rails root. This is where I want to put my application in the image, or sorry, yeah, in the image, and I'm going to put it at /project. And I just picked this name, and so that's where I'm going to put all of my files. That's where my Rails app is going to live. Part of provisioning the required dependencies for this box meant that I needed to install Node.js and Yarn. And two of the things that we all did when we installed Node.js and Yarn on our machines were these steps. And again, this is where we're curling a file and piping it to bash for installation. And it's adding Node.js to the source list and the Yarn to the source list. And so those things need to be run on the container. And then the next thing that has to be run is running apt-get and then installing at minimum build essentials, which is like the C compiler, GCC, so that the gems like Nokogiri that are actually C extensions, those can be built, installing Node.js, installing Yarn, and installing the Postgres dev header files. Docker, and another part of Docker that I haven't quite figured out is this idea that when you're building this image, it's built in sort of cacheable layers. And so that means like if I change something down at the end of this file and I've already built this image once, it doesn't necessarily have to rebuild these previous steps. But with everything that you do, every like run command that you do, that creates this cacheable layer, it makes your image larger and larger. And so one of the tricks that I've seen people do online is what I'm doing here, which is taking a single run command and like using the double and operator to chain a bunch of different commands together. And so in a Unix environment, you can run a command and then say and another command and another command, and you can stack a whole bunch of commands on one line and run them all at once. That's all I'm doing here, so that this will just generate one layer rather than 1, 2, 3, 4, 5, 6 layers. I don't know really how much that affects my image size. I've just seen a bunch of people do that online. And then I've seen that Docker also has released a new thing called multi-stage builds that supposedly removes the need to do this, so that you can do a whole bunch of preliminary building in one stage and then start with a fresh image and do another build after that. But I haven't gone there yet. So basically this is me installing into my container all of the OS dependencies. Then I specify what the working directory for this container is going to be, and I make use of that Rails root environment variable that I defined up top here. So when this container boots up, it's going to just default to the working directory being that /project folder. This next part is a little bit of a hack. I'm not happy with this part of it. I've got to think of something a little bit better here. This is okay. This is me putting Rails into production mode. So Rails will look for a Rails env environment variable to determine what mode it's in. But in production mode, Rails also needs something called a secret key. And this is one of the things that could be in that like credentials file that Jeremy was mentioning earlier. But what I would really like is I would like a different secret key base generated every time I instantiated the container. This is the encryption key that Rails is going to use as a private key to do things like encrypting the data that goes inside of the cookies that are sent to the end user, because those are not they're not decryptable on the user's side of things. So Rails stashes stuff in them, encrypts them, puts them in the cookie, and then when the cookie comes back to the server, it decrypts them. And so Rails uses the secret key base as a secret private key when it needs one. And so I've just hard-coded one in here, and that's less than ideal. Right? And you can generate these things from the command line by running like Rails secret, I think, and it just generates one for you. I was trying to come up with a way of like actually running that command and injecting it at runtime into my container, but I was already having enough problems getting this container to run, so I just hard-coded it in there. And the other thing a coworker was telling me about is if you put a .env file into your Dockerfile, it'll pull environment variables out of that as well. So that might be another route for me to generate the secret key base. But basically, I've just generated 2 environment variables here. Now I'm doing some copying. And so what I'm doing here is I'm going to my host operating system into the folder where this Dockerfile exists. That's the root of my whole Rails project. And I'm grabbing the gem file and I'm copying it to, I could have just done dot, meaning copy into the working directory. But in the things that I was copying and pasting, they just had to go gem file to gem file. But I'm pretty sure I could just say copy gem file dot, and it would copy it with the same file name. So I'm taking this and I'm putting it into my container. And then I'm taking the gem file lock and I'm putting it into my container. I don't take the entire application yet. I just take the gem file, and then on the container, I run bundle install. And I run it with a few switches, like, oh, don't bother installing any development and test gems. I don't know what this does. I copy pasted that. Jobs 20, I don't know. I was thinking maybe like it's gonna run this in parallel with 20 different jobs or something. I don't know, and retry 5, that makes sense. Like maybe it'll retry 5 times. I should probably look that up. Next thing I did, copied in the package JSON file into the container and the yarn lock file, and then ran yarn install. This is not required, this check files. That was just part of me when I was debugging things. It doesn't hurt, but it's not actually required. So after all these commands, we've got a Docker container based on the Ruby base image. It's got a root folder. I've been able to install the OS level dependencies. I've installed the gem dependencies. I've installed the yarn dependencies. And then this copy dot to dot copies everything else. That's my entire Rails app, copied from the host machine into the container. Final step is that thing I was talking about in the last video about precompiling the assets. This is going to turn all of the Sass into CSS. It's going to, if you have Vue in your application, it's going to transpile that with Babel and compile it all down and do all that fancy stuff. So it's making hard-coded assets for you that the browser can then load up when someone visits your website. So that's the final step. And this will build my image. So that's Docker on its own. And if I just wanted to use SQLite, I could be done there, right? I could just run this Docker container on my own. The problem with that, though, is just like Heroku, if I wanted to redeploy this or I change my Dockerfile, the Dockerfile, like Docker containers are supposed to be disposable. You're supposed to be able to grab them and throw them away and have no side effects. If I have my SQLite database inside of them, that sort of goes against this idea of it being like an immutable sort of throwaway disposable container. So then I brought in this concept of Docker Compose. So whereas Dockerfile is just like a custom file of commands, Docker Compose is a YAML file. So it is a YAML file. This is version 3 of the Docker Compose syntax. And here I've set up a few things, and I'll just use this to sort of open them up as I go. I'm going to create what's called a volume, and I'm calling it Postgres data. The reason I want to do this is, again, because these containers are disposable and I want to have a database in one of them, if I throw that container away or I need to cycle that container or change it in any way, I don't want the data associated with the database to go away. So what you can do in Docker is you can map folders in your container to folders on your host operating system, so that when the database gets saved, it'll save its contents actually into my host OS, so that I can throw that container away or reboot it or change it, and the core data doesn't change. And you can also set up these volumes to be like networked volumes, so they don't even have to be on the same machine. So one of the other things that DigitalOcean can build for you is networked volumes. So you could have it tied into a network volume potentially. Okay, so what else do I set up inside of here? Well, I set up 2 services. Each of these services is a container. I've got one which is the database. And here, I don't need a separate Docker file for it because I'm just going to wholesale take this Postgres image. And so I just mention it by name. I want a container. I'm going to call it DB. I picked this name. I could have called it database. I could have called it, Bob, but I called it DB, and the image is based on the Postgres image. So that's just the name of the image. In the docs for this image, it talks about sort of how to work with this image, how to extend it, and one of the things you can do is if you set up an environment variable, you can specify what password to use for the Postgres password. So here I'm setting up, I want an environment variable where the Postgres password is just the word Postgres. I want to make available to my other services port 5432, which is the port that Postgres runs on. So this is not exposing this port to the outside world. It's not exposing it even to the host operating system. It's just exposing it to other services. And then here's the volume that I'm mounting. I'm inside of my container, varlib Postgres data. That's where Postgres normally saves its data. That's going to be mapped to a Postgres data volume on my host operating system. So that's the database side of things. The app side of things, here I want to actually build a container based on the context of the current file system folder. and just based off of the Dockerfile that we just reviewed. So different from the DB where I'm saying pull from an image from Docker Hub, here I'm saying build from a Dockerfile in this current context. And when this Dockerfile boots up, run the following command. Initially, I just was running Rails S. I had to use this like B000 because it wasn't properly binding to localhost, and then this is the way of like forcing the Rails server to properly bind to localhost. And then I just explicitly said run on port 3000. I could have said 80 there too. The other thing that was happening with me is I was bringing these containers up and down, and I'm not sure if this has happened to any of you during your work. I know that it's happened to you, the PID file that hangs around. So you get this message saying like this temp PID file stuck around, and PID stands for process ID. It's a way that in the Unix world of saying like this is the OS level identifier for this thing. And what's supposed to happen when that thing stops running, it's supposed to clear away its PID file. And sometimes it doesn't. And so sometimes you have to manually just remove that. And so my little bit of a hacky fix here is like before running the server, I always just blow away that PID file, whether it's there or not. So it's a bit heavy-handed, but it did the trick. And then I made 2 environment variables available to Rails. I could also have pulled these environment variables here from the Dockerfile. Those could also be defined inside of here. I did this stepwise, so I put them in here first, and I didn't bother to move them over here. One of them is that database URL, that thing that we saw that Heroku was making available to us that we use inside of our database config file. So that's the fact that we're going to the environment variable and configuring our database based on the database URL. Now I'm doing that myself. I'm saying the database we're using is Postgres. The user for that database is Postgres. The password, which I've defined up here, is also Postgres. The host name is DB. That is this right here. So when Docker Compose brings your containers up, it makes a virtual network for you, and it puts each of these things up at hostname DB and hostname app. And again, these are just user-specified names. I could have called them anything, but there it is right here. And then the port is the port that I've exposed to the virtual environment. This one took me a long time to figure out. Rails serve static files. If Rails sees this, it's going to, it being Puma, the Rails server, serve up all those static assets that we precompiled. I'm not used to doing this because when I typically deploy Rails applications, I have Nginx running at sort of the front, almost like a proxy. And then instead of using Puma, I use something called Fusion Passenger that serves up my Rails application. And in that way, Nginx, I get to serve up all the static assets because it's a really, really fast server, HTTP server for serving up static files. In this case, I don't have Nginx available to me, so I need Puma to serve up those files, and by default, Puma doesn't do that. So by having this in place, I was able to get the static assets to be hosted. In development mode, I can set up, this is really neat. In development mode, I can set up another one of these volumes here where I can map the project folder, that's where my files are in the container, to the host operating system's local folder, so that when my container is running, I can edit the code on my host machine, and it actually is editing it on the container as well. So that way you could run Docker as a development mode thing, and as you're editing the files locally, they're changing live in the container without you having to rebuild the container. This is the thing that I woke up in the morning realizing I had to remove from my project. The thing that was happening to me is that everything was building, everything was working, but the static assets were never present. Even though I had set them to be served, they were never actually present inside of my container. And the reason they weren't present inside of my container is that I had set up this volume, and it was overriding the project folder on the container and just pointing back to the folder on my host operating system and the static assets weren't there. They had been precompiled inside of the container. And so over and over, trying all these solutions to expose the static assets, and they were never there, and I couldn't figure out why they weren't there, and it's because I had mapped this volume. So you would only want that volume mapped in development mode when you don't need to worry about assets, and it would just help you so you could edit files locally and have them change inside of the container. But once I removed that, things finally worked. Ports, so I'm exposing port 3000 to port 3000. I could also expose port 3000 to port 80, the more standard web port if I wanted to. And then you can set up dependencies between containers. So here I'm specifying that the app container depends on the DB container, so that anytime I bring up app with Docker Compose, it'll automatically bring up the DB. I can also add to each one of them this restart always. And that way, if I run Docker Compose in what's called detached mode, I can then like log out of my server and even reboot the server, and everything will just start back up again. And so it's almost like having all of this running as like an OS level service, so that even if the whole machine needs to be rebooted, restarted, these things will just come back online. So with all of this in place, I get my Docker service. So when I ran on my local machine here, when I ran the command docker compose up, that parses that file. It brings up the DB, it brings up the app. This is Postgres, a little bit of output. This is Puma, a little bit of output, and it's just running locally. If I want to run that up on DigitalOcean, well, my server is now operational here. I can copy that, and I can go to a WSL prompt, and I can SSH. I want to SSH in as root. And because it put my public key, my SSH public key into the droplet, I can just log in. So now I am, who am I? I'm root. I'm root on this box. I can now use git. I want stung IRC. And I can grab my repo. Grab that here. Git clone. I have to make one change, just a small one. The version of Ruby in the container is 2.6.5. My app was written on 2.6.3, so I needed to change that. And leave that file. There's also like the hidden Ruby version. I only think that means anything when RBEMV is installed, but I'm just gonna delete that just in case. And now I should be able to type docker compose build. And this is going to go to my Docker compose file and see that it needs to build the app based on the Dockerfile. So it's going to go and download the base image. So this is that from command. So it's basically stepping itself line by line through this, because it saw when I requested a build that there was one of my services that required a build, which was the app that needed to be built on the Dockerfile. And so first thing first, it set the base image. It's now downloaded that base image and it's extracting it. And then piecewise, we're going to see it do the setup for Node, the setup for Yarn. It'll do this apt-get. It's going to install my bundle install. It's going to install my Yarn install. Copy the entire app over. It'll precompile my assets. At that point, the container will be built, so it will run this command on it. And then it'll notice that it also depends on the DB. Oh, it won't yet run the command on it because I'm just building. So it'll just stop at that point. I'll then have to do my migrations, and then I can run docker compose up. At that point, it'll run the command on the app server. It'll notice that the app server depends on the DB server, and it'll bring it up as well. And my whole app will be operational on port 3000 on this DigitalOcean droplet. So you can see here, it's going through the apt-get install steps right now. So while it's doing that, anyone have any questions or comments or concerns about our sort of quick introduction to containers, and then specifically containerizing a Rails app in production mode? Yes, for the JavaScript assets, it is. For the like SCSS and the image assets, it's probably still using Sprockets, which is like the Rails asset pipeline that we used before Webpacker. So for the JavaScript assets, yes, it's definitely using Webpack for that, and it's going to compile them all down to just to files, and it's going to put those all into the public assets folder. So I don't know if necessarily we need to watch this go through all of its steps. The end result is exactly what's happening over here inside of my Windows machine. The only other thing that I would like to show you, because if we're not going to watch this go through all its steps, is just how I was actually able to run the seed script and the migration script. So I'll just show you that from PowerShell here. I can see that the font is really, really small. Let me just edit that quickly. Oops. Right on. So that we don't have to wait for that whole process to get through. When I want to run something in a Docker container, and I've got Docker Compose going, well, I can show you a few things here. Docker Compose PS will show me any of the processes, any sort of Docker processes that are up and running. So right now, because I killed that Docker Compose command, neither of the two containers is up, so they're both at state exit. I can run Docker Compose images, and it'll show me like the two images that are available to me. So you can see the Postgres image. It's pretty small. It's like 300 megs, but you can see that my image is like 1.35 gigs. It seems like Postgres should probably be bigger than my tiny little Rails app. So I don't know. I haven't quite figured out how to make this any smaller. One of the things that I was starting to play around with last term was a flavor of Linux called Alpine. And so it's just like a minimum tiny, the base image is 5 megs. And so when I started building off Alpine, there's Ruby Alpine as well. So it's like Alpine with Ruby pre-installed. I was able to make my images a lot smaller. And I was also able to, there was a few programs that I could run on my images that would like process the images and sort of squeeze them, make them tinier. But yeah, the last thing I'll show you is just this ability to run commands on a particular container, commands like Rails db migrate. And so that just like boots up the containers and runs them. There was nothing for it to do because I previously already run it, or Rails db seed, for example. And yeah, so that's the same kind of steps that I will eventually have to run over here. So this is still in its building stage. It's still building the image. So after this image would be built, I would do those two things. I would run Rails db prepare, I would run Rails db seed, and then I would finally run Docker Compose up. If I wanted it to stay up, I would run Docker Compose up space -d. That's running Docker up in detached mode, meaning it's running in a way that's detached from your shell. so that if I exit out of the application, it keeps running. And so that's it. That's all I got for you in terms of deployment using Docker. Even if you aren't going to use Docker for your application, it's a highly sought after technology. Before Skip the Dishes was purchased, one of the technical requirements for the purchase from their parent company now was that their entire infrastructure had to be containerized. And so they did a mad dash of like containerizing all of their microservices before the purchase actually went through. That's all I got for you for today. Thank you very much for coming to class and listening to me talk about Docker. This was your very last lecture of the year.